Okay, so we are now looking at the assignment, and we'll start with question 1. This assignment had 2 questions. Here's question 1, which was on inventory management, and then question 2 was on forecasting and forecasting techniques. So getting down to the question here, the question reads: the confectioner buys plastic boxes in bulk and uses them to pack chocolates. The annual requirements of these boxes is 1,200, which is the annual demand, and each box costs $30. So meaning this is the acquisition cost per unit. The ordering and carrying cost $10. That is the ordering cost, and then the carrying cost is 20%. And I have to make mention here that the carrying cost is always the percentage of unit price. No, it is the percentage of acquisition cost. That is the carrying cost. It's also called the holding cost. Carrying cost is also called the holding cost. Now, the supplier from whom the confectioner purchases these boxes sells them only in the lots of 25, meaning that they can't sell anything less than that. So meaning they are selling in the batches of 25. It's more like the multiples of 25, meaning that we can go for 25, 50 boxes, or going to 75 boxes, or 100 boxes, or 125 in the multiples of 25. That is, you only purchase quantities in multiples of 25 boxes. That it is indicated here. Now, how many boxes should the confectioner order so as to minimize the inventory total stocking cost? Now, when you're talking about total stocking cost, there are 2 costs that are involved in total stocking cost. We have the ordering cost. So here, talking about the first aspect is on ordering cost. When you're doing stock taking, you look at how many units you ordered. So we have the ordering cost, and then we also have the carrying cost. So ordering cost and carrying cost. These are the costs that constitute the total stocking cost. So ordering cost and the carrying cost. So these are the 2 costs relating to the stocking cost. So when you're carrying out the stock taking in every organization, we look at what we actually carried to today plus what we have ordered today. That is on the total stocking cost. So we have been given the information there that we need to go a little bit deeper. So that's for part A. We need to find how many boxes the confectioner should order to minimize the inventory cost. That is the aspect of the ordering cost and the carrying cost. Getting down to the second part of the question here, part B, if the supplier offers 2% discount in the cost of each box when the purchases are in the quantities of 300 at a time, should the confectioner accept this offer? We will get into an evaluation to determine if the confectioner can accept this offer or can reject the offer. Number C, suppose the supplier has decided that instead of a 2% discount over the following price breaks will be used. So we're talking about the order quantity less than 100, the cost per box is, so meaning that should you order anything less than 100 boxes, the cost per box is $30. Should we order between 100 to 199, the price is reducing a little bit. So we are getting to 29.75 as we order between 100 to 199. Should we order 200 or more, the price has gone down a little bit again. to $29.6 dollars. Then what order quantity should the confectioner make? So this marks the end of the first part of the question that we need to actually look at. All right, so we can now get down to the solution from what we've been given. The confectioner buys plastic boxes in bulk and uses them to pack chocolates. Annual demand, which is a D, the capital D, is 1,200, and the cost per box is $30. The ordering and the carrying cost are $10 the order and 20% respectively. So we can find how many boxes the confectioner order. So we can look at the economic order quantity. So here, our D is our annual demand. So this one is annual demand, which is the capital D. So this one is our annual demand. Then we have the other one here. We are talking about our S. Our S is the ordering cost per order. So our S is ordering cost per order. This S is a ordering cost. So this one is our ordering cost. So we have this one as ordering cost. So, all right. Then getting down to the other one here, this is the carrying cost, which is the percentage of unit price. So carrying cost is so this one, our C is the carrying cost, which is the percentage of unit price or acquisition cost per unit. So we have to get deeper here, where we need to get into the details of this question. Now, our carrying cost is going to be, we have to go back to the question here and check. Our carrying costs, they have told us that the way they are arranged here, the ordering and carrying costs are $10 per order, that's the ordering cost. And then the carrying cost is 20% of the unit price. Our unit price, we have been told that each box costs the $30. So each box is costing $30. All right. So since each box is costing $30, the carrying cost is a percentage of acquisition cost of $30. So our carrying cost is actually going to be getting down to what we've been given is 20%. So it's 20 over 100. So it's 20 over 100. I'm sure people are able to see. So it's 20 over 100, then multiplied by the acquisition cost per unit, which is $30. So this is where our carrying cost came to 6. So our carrying cost is 6, the one which is given here as the carrying cost, because it's just the percentage of unit price. Percentage was given as 20%. So we have gotten our EOQ of 63. Our EOQ is
Yes.
Our EOQ is 63.25. Right. So what we are trying to say here is that we now need to identify one thing that has been given the question. In the question, they have stated that the supplier from whom the confectioner purchases these boxes only sells them in the lot of 25, meaning that the 63 is not good enough, because the 63.25 falls between 50 and 75. The reason why I'm saying 50 is because we are only buying in multiples of 25. So if 25 is not enough, we need to buy 50 boxes, or we can get into 75 boxes. So we have to just check now that unless this the EOQ was exactly 25 boxes that we found would have been better. Or if we found 50, it would have been okay, because we are just purchasing or ordering in multiples of 25 boxes. So we cannot order anything less than that. If 25 is not enough, we can't order 30 boxes. No, because we are ordering in the multiple of 25. It has been stated here, we are ordering in multiples of 25. So this is the reason why we can't go for anything less than that. So this 63.25 falls between 50 boxes and 75 boxes. So we have to find now the total, because here we are looking at how many boxes to order in order to minimize the inventory total stocking cost, where we're looking at the ordering cost and we are looking at also the carrying cost. These are the two components that constitute the total stocking cost. So we need to find the EOQ at 50 boxes and the EOQ at 75 boxes. That is it. That is it. The total stocking cost at 50 boxes, because the 63 is not good enough. We can't go for it. So we need to find the total stocking cost. Or since we are selling supplier sales in 25, so we need to find that. So our total stocking cost formula is given by, this is annual carrying cost and this is annual ordering cost. So annual carrying cost and annual ordering cost. So we substitute here to get the total stocking cost. TCE simply means total stocking cost. Looking at total. So this is our total stocking cost. So this is total stocking cost at Q of 50, because the 63.25 falls between 50 and 75. All right, so meaning that we can substitute here in the formula and get what we are supposed to get. So our Q is 50 divided by 2. This is annual carrying cost and this is annual ordering cost. So we can substitute and get the values. All right. So this is it, what we are getting. The carrying cost is 0.2 multiplied by 30, which is a 6 pounds there. Then our Q, we are using our Q as 50 in this case. And then our 2 is constant, is part of the formula. Then S is the ordering cost, like I mentioned here. Our S is ordering cost. I've given the composition of whatever needs to be explained for people to understand. Getting down to this, ordering cost is 10. Our annual demand is 1,200. And we are actually looking at 50, because this one is in between intervals of 50 and 75, like I mentioned, please. So we are getting the total stocking cost at 50 is $390. So our TSC, when we are to purchase 50 boxes, we are simply saying we are getting the $390. Now we need to get down a little bit to find the total stocking cost at 75 boxes. So total stocking cost at 75 boxes, we get down to the formula. The first part of it is called annual carrying cost. Annual carrying cost. This is annual ordering cost. Carrying annual ordering cost. So the 0.2 is a percentage that has been given in the question by the examiner, 20%. So 20% of the unit price, which is the 6%, is the 6 kwacha or $6. And then here we are getting down to our Q is 75, then divide by 2. Our 2 is a constant number that is part of the formula. Getting down to the ordering cost, which is 10, then the demand is 1,200. We divide by 75, which is for the Q. We are getting the total stocking cost of $385. That is the total stocking cost. So this is the $385 that we have. All right. So this is what is going on here. So we are getting down to $385. We are purchasing 25. Now, at 50 boxes, we are getting $390. So of course, we can see from here that it is cost saving to buy more boxes than buying the other boxes. At 50 boxes, we are getting $390. We are spending that much. As we are buying 75 boxes, we are getting down to $385. So this simply indicates one thing, that it is worthwhile for us to actually go for 75 boxes. So the confectioner here should order 75 boxes. Okay. So the confectioner should order 75 boxes because it is cost saving. So the quantity of 75 boxes gives the least total stocking cost, and the confectioner should buy or order 75 boxes in this case. All right, so that answers the first part of the question. This is part one, question one with assignment. Getting down to part B, or question B, where we are now looking at if there's a discount now. So if we are now saying if there's if the supplier offers a 2% discount on the cost of each box when the purchases are in quantities of 300 at a time, should the confectioner accept this offer? All right, then they've given us an option. If the supplier offers the 2% discount on the cost of each box when the purchases are in quantities of 300 at a time, should the confectioner accept this offer? So what goes on here is that this 2% discount, we are going, instead of getting buying each box at $30, they have given us a discount of 2% because we are buying more. We are buying in quantities of 300 at a time. So now what is going to happen here is that we are going to, this is part B. So we are going to, so currently the confectioner orders 75, because 75 is what we have concluded here at part question A for the first question. Then in part B, we are simply saying that currently the confectioner orders 75 boxes and has been offered a 2% discount if he orders 300 boxes at a time. Therefore, we're supposed to calculate the total material cost for both quantities. TMC simply means total material cost. So we are talking about total material cost. So we have total, okay, so this TMC means total material cost. All right. Then the other one, the TSC, was the total stocking cost. So now the formula for the total material cost has been given here, where we need to look at the annual carrying cost. And we have also, this is annual carrying cost, the annual ordering cost, then acquisition. Acquisition cost multiplied by annual demand. All right. So we have, this is what happens here. So we need to compare the total material cost at 300 and the total material cost at 75 boxes, because we recommended 75 boxes in the first part of the question. So is it worthwhile to continue buying 75 boxes, or is it worthwhile to go for 300 boxes, all right, of these plastic boxes? So we have to get down here where we say our quantity of 300, we can find the total material cost at 300. Now here we are supposed to now find at Q equal to 300, we have to find our total material cost. So our total material cost at this junction, we're going to put our TMC is actually going to be, we know we have the formula there. It is Q over 2. Then you multiply this by C. Then plus the other one is D, which is annual demand. Then we divide by Q. Then we multiply by S. All right, then plus acquisition cost, then multiplied by annual demand. So this is what is going to happen. Now at Q300, there's a discount on the unit price. So that's a discount, 2% discount. So we are supposed to be buying each box at $30. Now, in this case, they have told us that if you are buying in bulk, they are giving us a discount of 2%. So a 2% discount, you can just simply say 2 divided by 100, then multiplied by $30. So $30, we are getting the value of a discount. So the discount here is going to be the 2 divided by 100 times 30. They have given us a discount of 0.6 ingwe. So 0.6 ingwe is a discount they have given us. So 0.6 ingwe is a discount they have given us. So meaning our price here, our net price will be $29.4 dollars. That is it. Our net price, that is supposed to be the value at which we're going to buy this, each box. So our total material cost now in this case would be, our total material cost is actually going to be our Q. We are going to put the Q is a 300 at this time. Then we are going to put here 300. Then divide by 2, then our carrying cost will still remain, as carrying cost is a percentage of unit price. So it will be 20% over 100, then multiplied by 29.4. So 29.4. So this is only our carrying cost. So our carrying cost for this one is actually going to be 20 divided by 100 times 29.4. So it will be 5.88. So we're going to use it 5.88. as our carrying cost. So 5.88. Okay, so this is only the carrying cost. So as we substitute here, 300 multiplied by 5, this is 5.888. Then plus our demand is 1,200. So it's 1,200. So our demand, we have 1,200. Then you divide this one by 300. Then we actually multiply by the setup cost. In fact, this is when we're still ordering. So multiply by 10. Then plus the acquisition cost per unit is now 29.4 dollars. You remove a quarter there. Supposed to be in dollars. This question was in dollars, so everything else supposed to be in dollars, because that's what the examiner had indicated in the question. Okay, then multiply by our annual demand of 1,200. So aggregating to find the sum. So this is 1,200. So finding the sum here, we can get our total material cost, where we can break down. The first one is 300 divided by 2, multiplied by 5.88, which is 888, which is found here as the holding cost. 882. This is what is there. So this one, you can check it out in this one. Then plus the other one here, which is 1,200 divided by 300 multiplied by 10, which is a 40 here, which is up there that can be seen. Okay, so this is a 40, which is this one, which is the ordering cost. Then getting down to the other one, where we will multiply that one because of the discount they had given us. Okay, so meaning that we are getting the other one is 35,280. So 35,280. So after aggregating these ones, we can find the total. Okay, so the total material cost is actually giving us the figure of 36,202. 36,202. I'm sure the way I'm explaining here, people are able to see. Okay, so 36,202. 36,202. All right, so this is it, what is going on here as we are looking at this one to do with ordering 300 boxes and ordering, or can we continue ordering the 75 that we recommended in the first part of the question? All right, so this is what we have gotten, 36,202. Similarly, we can also get down to the other one here, where we now look at can we order the 75, the current one that we are ordering, the current boxes of 75. So at Q75, we are going to compare which one will be cost saving, which one will be cheaper between the two ordering policies Okay, so we have at 75, our total material cost, TMC, the formula is still there. We are going to use the same formula as we order the 75 boxes. All right, so meaning at 25 boxes, we are simply saying there is no discount. So meaning we are still purchasing at $30 per box. So meaning our carrying cost, we are going to put 75 here, 75 over 2, which is a standard number, then multiplied by the other one, which is multiplied by the other one, which is the carrying cost. So carrying cost, then plus the carrying cost is 6 kwacha here, or $6. Then plus our annual demand is 1,200. Then you divide it by, so 1,200 divided by 75. So divide by 75, then which is the Q, then multiplied by the ordering quantity of 10. So quantity of 10, then plus the unit price in this case is $30. $30 here, then multiplied by 1,200. So this is what goes on. So meaning our total material cost when we are buying 75 boxes, we have the annual carrying cost. So annual carrying cost will be 75 divided by 2 multiplied by 6. I'm just trying to explain where the figures are coming from. So the 225 here, which is already there. So I'm showing. Recording in progress. All right. So that is what's happening. So this the 225 is already sorted out there for when buying 75 boxes. So we have the 225 down here. That's where it's coming from. This 225. Then plus the other one, which is the 1,200 divided by 75 times 10, which is 160. So that's where the figure is coming from. So we have 160 here. Then we need to also check the other one. The other one is 30 multiplied by 1,200, which is 36,000 that we need to have on the unit price multiplied by annual demand. So we have 36,000 here. So meaning that our total material cost for this one, we are going to have the final figure here of 36,385. 36,385. So 36,385 is our total material cost. So what is important here to note is that we need to now find the compare the answers actually. We have the 36,202 when we are actually buying at 300, buying 300 boxes. We are only spending, the total material cost is $36,000, that is 36,202. Then the other one is 36,385. So meaning that it is cost saving, okay, to buy 300 boxes instead of the 75 boxes, because the total material cost as we purchase the 300 boxes, we are getting the $36,202 Then the other one is $36,385. So we should, according to the question, part B of the question, if the supplier offers 2% discount on the cost of each box when the purchases are in quantities of 300 at a time, should the confectioner accept the order? So the confectioner should accept this offer because the total material cost as we purchase the 300 boxes is cheaper than that of 70 when buying 75 boxes. All right, then we can go to the last part of the question, question 1, part C of the question, where we are saying, where the examiner wants to find out if we can buy when there's an order quantity for the discount. So suppose the supplier has decided that instead of a 2% discount offer, the following price breaks will be used. So when we order less than 100 boxes, the cost per box is $30. When we order 100 to 199, the cost per box is $29.75. When we order 200 or more, the cost per box is $29.60. So which order quantity should the confectioner make for part C? So part C, we need to actually compute EOQ for each acquisition. All right. So for meaning that for the first range here, we are supposed to find EOQ for all ranges. For all the ranges of order quantities, we find the EOQ for all ranges. Okay. So meaning that for the first range, there's no discount. We are still buying, because anything else that is less than 100 boxes, we are buying, the cost per box is $30. So our carrying cost for this one will still be 0.2. So our 0.2 multiplied by 30. That's how we find the carrying cost for this one, which is the ordering cost, which will give us the $6. This other one will be 0.2. So 0.2 multiplied by 29.75. So 0.2 multiplied by, so 0.2 here, then multiplied by 29.75, which is our carrying cost for the second one. Then we also have to find the carrying cost for the other one, where we are getting the figures. So meaning the carrying cost that we're talking about, these ones here. So we are going to find EOQ for all ranges. So first one, we are saying 2 is constant. So 2 ds over c. The same formula applies. Okay, for economic order quantity, the EOQ simply means economic order quantity. So we are going to have the other one. So here we have the 2 multiplied by 1,200 multiplied by 10 over the 0.2 multiplied by the 30, because for the first range, we are not given any discount, because as we buy less than 100 boxes, we are simply saying we are still buying a box at $30. Then should we buy 100 to, so meaning anything less than 100, meaning that from 0 to 199, from 0 to 99 boxes, we can buy at $30 per box. They are not giving us any discount there. And then from 100 to 199, we are getting 29.75. They have reduced the price a little bit. And should we buy 200 or more boxes, again, they have reduced the price a little bit. So we need to make a decision of what should be our order quantity as we look at part C of this question. All right. So getting down to this one, we are going to have our EOQ for oranges. So first one, this is when we are buying less than 100. So we are buying, this is it, less. Okay, so we can simply say less 100 boxes. So less 100. We are not given any discount. Okay, so can we take advantage of the quantity discount? So here we have gotten, this is our EOQ when we are buying less than 100, but we are buying in multiples of 25. So meaning the 63.25, we had chosen our EOQ here, which was the cost effective that we recommended. Our EOQ was at 75, was 63.25 is not actually feasible. So we are supposed to go for 75. Okay, so 75 is it what we're supposed to go for. Then the other one, we are supposed to buy in the range of 100 to 199. So we need to find the EOQ first before we make a conclusion on the second part of it. So here we are simply saying our EOQ, this is when it is between 100 to 199. So let us find the EOQ when we have this range. Okay, so a range of 100 to 199. What is going to happen there? So we have found the EOQ of 63.51 boxes. Now the 63.51 boxes, this is not feasible because we should buy in the range of 100 to 199. So our Q we should select in this case here should be 100, where the lower bound begins. So we should select the 100 because the 63.51 is not feasible. So we need to get our Q of 100. This is what we should go for. Because this 63 does not fall in this range. It doesn't fall in this range. It's not within that interval. So it's not feasible. So we should go for the minimum of the lower bound. So 100 is okay. And this 100, why is it okay? It's because it is also part of the multiples of 25. 25 can go into 100 without leaving any remainder. All right, then we go into the other one. The other one, we should buy 200 or more boxes. So 200, we are trying to weigh the options of taking advantage of the discount. All right. So we're trying to take advantage of the discount. Can we take advantage of the discount? So we are going to buy 200 or more. When we say 200 or more, it can be 200 up to whatever value that we don't know. Well, maybe up to 1,000, maybe up to 1,500, maybe up to whatever value. The price will still remain at $29.6 per box. All right, so we need to go a little bit further here, where we now need to find the EOQ for this same range of 200 or more. So this is 200 or more. Our EOQ we have found is 63.67 because our carrying cost was 20% of acquisition cost. Acquisition cost per range was not the same, differed because of the fact that the prices were reducing per box based on the ordering policy. So at Q75, we are getting the total material cost. Substituting in this total material cost formula, we are getting our total material cost the acquisition cost was still at 30 because of no discount, multiplied by 1,200. So our total material cost was $36,385. So this one is not feasible for EOQ for the third range, where they are saying we're supposed to buy 200 or more. The EOQ of 63.67 boxes was not feasible. So what we are supposed to do now here, we're supposed to get our Q of 200, because that's where the feasibility would have started from. Because we are saying we're supposed to buy, when we buy 200 or more boxes, that's when that price will be feasible. That's when that discount of 29.6, that's when it will be given to anybody who is buying, or someone who's buying 200 or more boxes. That's when the $29.6, that will be the acquisition cost per unit. When we are buying 200 or more boxes, this will be the price. All right, so we're getting down to the total material cost for this one. Okay, total material cost for at Q200, our total material cost is actually, we're supposed to substitute here the carrying cost, where the 5.92 came from, is a multiplication of the 0.2 by 29.60. The carrying cost is always the percentage of the unit price. Take note of that. So that's why we're having the carrying cost of these values. The ordering cost, we're supposed to substitute, but here we are buying at 200 boxes because the 63.67 was not feasible. We're supposed to buy the minimum 200 or more boxes. That's how come even the 63.51, like I mentioned, was not feasible because the interval is supposed to be 100 to 199. So we had pushed our Q to 100 because this is where the feasibility would have started from. All right, then, so we substitute here. So we are getting comparison, the total material cost at 100 boxes. If you have to buy 100 boxes, total material cost, we're substituting in the total material cost formula the unit price or the acquiring cost. The acquisition cost per unit here was 29.75 because of the taking advantage of the discount. The first one, there was no discount because when we were buying anything less than 100, there was no discount. Then the other one here, the acquiring cost was 29.60 multiplied by annual demand. So we're comparing the total material cost among these various ordering policies. We can see that buying the cheapest mode here, the cheapest total material cost is 36,117.5. So that the confectioner should order 100 boxes, resulting in the least total material cost of 36,117.50. 36,117.50. So this is what goes on this question here. So we have the cheapest order quantity here, or total material cost, is that of 36. So 36,117.5. So the confectioner should buy the order quantity, our Q should be equal to 100 boxes. Okay, so this marks the end of the question 1 of this assignment. All right. So looking at question 1 through to question 1 part A, question 1 part B, question 1 part C, we have explained whatever we're supposed to consider here when looking at this question 1. So we have done question 1A, question 1B, question 1C. Unless there are any questions. All right, so if there are no questions, in another class, I'm going to explain question.
Is it possible to send it? Hello?
Yes, please.
Is it possible to send the videos? I joined it a bit late.
No problem. The video, you're going to send you the video. There's no problem about that.
Okay, thank you.
All right, then. So in the other class, we are going to look at question 2 of this assignment paper. So we'll look at question 2. This question 2 is on a different topic. This one is on forecasting. So in the other class, we are going to look at this question 2 on forecasting. So to explain what is forecasting and the techniques, forecasting and forecasting techniques. So we can end here for now.
Thank you.